Hi guys, let's understand much more about dimensional analysis and applications of dimensional analysis. First of all, what is this dimensional analysis? So it's a kind of study, the studying physical phenomena on the basis of dimensions. So if we can study deeply about the dimensions and if we can analyze that, we will get certain results. So under that, very first important application, to convert a physical quantity from one system of units to another. So let me take an example. So we know that force force is a physical quantity in SI system, Standard International System of Units. Its unit is nothing but Newton. Force units are Newton, and we already know that it's a dimensional formula m l t power minus 2. These are the units. Suppose I would like to know what are the force units in CGS units. What are the force units in CGS units? So in SI unit we are calling that as a Newton, but in CGS units we don't call that as a Newton. We call that as dyne. So that is the CGS units we call force units as dyne. And here if I take 1 Newton, so in the SI unit equal to 1 Newton, in CGS units it is how many? It may be 1 or 100 or 1000. So how we can come to know that? So if you analyze the dimensional formula of the physical quantity force at here in one system of units, so we can easily find it out. It's another system of units, the same physical quantity. Suppose if Q is a, let me write it here, if capital Q is a dimensional quantity, a physical quantity, capital Q is a physical quantity. So likely here the physical quantity which I have taken as a force. If capital Q is a physical quantity, and to this physical quantity, if N1 is its numerical value, numerical value means how much? Here I have taken 1. So 1 is its numerical value. And if you take that U1 is its units. So here I have taken units are Newton. In one system of units. So these two comes under one system of units. Let this system of units you take as SI unit, system of unit. Now to the same physical quantity, Q, if N2 is its numerical value in another system of units. I don't know here in this case how much it is. So this is, I want to figure it out. Another system of units, and U2 is its units in another system of units. So here the units are, I have taken as dyne. So in a simple question, 1 Newton equal to how many dynes? Now to figure it out that, the physical quantity is same in both of the cases. So we can write that Q equal to a basic formula to find it out. This Q equal to N1 U1, which also equal to N2 U2. Since the product of numerical value and its dimensions or units, which equal to the product of numerical value and its dimensions in another system of units. Suppose in this case, this you take as a system of units, and this case you take this as CJ system of units. So how we can solve this? So to solve this, let me take as an example, let M1, L1, T1 be the fundamental units of length, mass, time in one system. And M2 and L2 and T2 are the fundamental units in the another system. If that is the another system. Suppose I have taken a physical quantity. That physical quantity That physical quantity is capital Q. It is having a dimensional formula. So M power A and L power B and T power C. Just a formula. Now I can write this dimensional units formula into system of units. Then I can write this as U1 equal to, this formula do not change, but M1 power A and L1 power B and T1 power C, and U2 equal to, we can write that as M2 power A and L2 power B and T2 power C. So this is the units in the another system of units, U2. Now if we can use this formula, that is the physical quantity is same, so in the both system of units the same physical quantity we are going to find. So I can use that formula N1 U1 equal to N2 U2. So if we can write that at here, so N1 times U1, U1 here equal to M1 power A and L1 power B and T1 power C, which equal to N2, which is the another system of units, N2 times M2 power A and L2 power B and T2 power C. So in this case I need to find the quantity of N2. So that's my task, because I want to find what are the system of units N2 in dynes. 1 Newton, 1 is the in the SI unit, in the dynes how many it will be. Now to find the N2, so what you can do it, you can just divide each other. Therefore N2 equal to N1 of, now we can divide one over other, M1 upon M2 power A and L1 upon L2 power B and T1 upon T2 power C. Now this much if we can do, we can get that how many dynes will be equal to 1 Newton. So like this if we can do, we won't get any proper knowledge. So let me take an example directly. Example, let us convert 1 Newton 1 Newton into dyne. So newtons are the SI unit system of units and dynes are the CGS system of units. Now here I can write, first I will write the dimensional formula. SI unit is force. In the SI unit I will take it here, and CGS units. So here it is force and here it is called as dyne, and here the dimensional formula we can take that m l t power minus 2. It's supposed to be square bracket. And if I can convert this into standard formula by comparing the standard formula m power a, l power b and t power c. So here a equal to 1 and b equal to 1 and c equal to minus 2. If you can compare these formulas, these powers. So after comparison, so in SI unit, N1 value is given. N1 value, the quantity is 1. It's 1 Newton. And the corresponding N2, so here we need to figure it out how many are there. So in terms of dyne. And if you can know the force formula, F equal to force equal to mass times acceleration. So if you can rewrite that, mass and acceleration equal to meter per second square. On the left side, it's supposed to be the 1. It means the force equal to 1. So the mass also should be 1 kg and the length also should be 1 meter and time also should be 1. So then only we can define as this 1 Newton. It means on 1 kg mass, if x in a time of 1 second, the acceleration produced is 1 meters per second square, then we can define that as 1 Newton force. On the left side it's supposed to be 1, so then on everything in the right side also should be equal to 1. So now here I can take that physical quantity m1 equal to 1 kg, which also equal to 1000 grams. So here m2, it's only 1 gram, here no need to convert again, and L1 we can convert that 1 meters. So 1 meters is nothing but 100 centimeter, but here L2 which gives only 1 centimeter, and the time t1 equal to 1 second. In the CGS units, the time t2 is also becomes 1 second. Now after converting the given physical quantities in terms of the SI units and CGS units, now here I can apply the same formula. N2 equal to N1 of M1 by M2 whole power A and L1 by L2 whole power B times T1 by T2 whole power C. Now N2 equal to N1 of, you can put the M1 values. So M1 here equal to 1000 grams and here equal to 1 gram. So if you can write that 1000 upon 1, both are gram. So these both are grams, whole power A. Not this whole power A, it's in the dimensional formulas, that is whole power 1. Because here we have written that the powers also. The powers value here we have, these are the powers value. So the powers value here, the a power 1 and the b power 1 and the c power minus 2. So here the whole power 1, and for the L1 equal to 100 centimeter upon L2 equal to 1 centimeter whole power 1, and the time 1 second upon 1 second whole power minus 2. Now if we cut the corresponding units, grams gets cancelled, centimeter gets cancelled, and times gets cancelled. Now if we can write N2 equal to N1. N1 value also we are having. So N1 value we are having, it's only 1. So we have taken N1 as 1 Newton. So this is the value of N1. So we have considered that as N1 equal to 1. Now if you can do further simplification in this case, that is N1 times 1000, if you can write that as 10 power 3, 10 power 3 whole power 1 also gives 10 power 3, and at here 100 you can write as a 10 power 2, and this you can write as 1 power minus 2, or 1 power minus 2 if you can convert that. So N2 equal to, if you can multiply this everything, 10 power 3 and 10 power 2, it becomes 10 power 5. Upon this if you can write as a denominator 1 square. So it's always gives the value of 10 power 5. So now we got the N2 value equal to 10 power 5. So these corresponding units, what you can write? Dynes you can write. So therefore finally I can write that 1 Newton equal to 10 power 5 dynes. So here we have taken 1 is a measuring unit, the corresponding numerical value in SI unit. So here 1 is numerical value, number, and Newton becomes unit. This everything is in terms of SI unit. And on the left side if you can see, so here we got the same 10 power 5 numerical value, it's a number. And dynes are the units. In everything is in CGS units. So 1 Newton equal to 10 power 5 dyne. So this number we calculated by using dimensional analysis. So this is the how we started, by taking the corresponding physical quantities in the both. It's not very tough, but just we need to concentrate much more by taking this formula. So if you can repeat certain examples carefully, so we can understand that very better. So let me take one more example for gives better understanding. Let's do this example. When 1 meter, 1 kg and 1 minute are taken as fundamental units, the magnitude of force is 36 units. What will be the value of this force in CGS units? So here the physical quantity is given for us force, and force we know the dimensional formula mLT power minus 2. And if you can compare with this, the standard dimensional formula m power a and L power B and T power C. Here A equal to 1 and B equal to 1 and T equal to minus 2. So first we need these quantities. And we know the formula. So the formula, what we can write, that Q equal to the physical quantity Q equal to N1 U1, which equal to N2 U2. So the force N1 value is also is given. So here N1 equal to 36 units number, and we need to find that N2 equal to how much. We will use the same formula, N2 equal to N1 upon, what's that, M1 by M2 whole power A and L1 by L2 whole power B and T1 by T2 whole power C. So N2 equal to, N1 is given that 36 and M1, so here M1 is mass 1 kg. In CGS units, that if you can convert that in terms of grams, 1000 grams. And L1 length equal to 1 meter, so that is also gives that 100 centimeter. And time T1, which is given 1 minute, which gives to me 60 seconds. So that is the units in SI system of units. So this I can take that as SI system. The same quantity in CGS system. So M1, which becomes, M2, the quantities, this is M2 becomes as 1 gram, and L2 is becomes 1 centimeter, and time T2 becomes 1 second. So that will becomes CGS units. Now if you can substitute the corresponding values, M1 here given that 1000 grams upon M2 is 1 gram, whole power, the A value goes to 1, and L1 is 100 centimeter upon L2 equal to 1 centimeter. It's the B value is 1, and T1 upon T1 equal to 60 seconds and T2 equal to 1 second whole power minus 2. Now to find the quantity N2, here we need to simplify. N2 equal to 36 of grams gets cancelled, it becomes 10 power 3, and here becomes 10 power 2, the centimeters gets cancelled, and here the seconds gets cancelled. So here you can get that 1 over 60 square. 1 over 60 square. Now if you can simplify that, N2 equal to 36 times, on the numerator you can get 10 power 5, on the denominator we can get that 60 square, it means 3600. 60 times 60. Now 36 gets cancelled, and here becomes as 100. So this 100, if you can take to numerator, it becomes 10 power minus 2. If you can do this simplification, the value of N2 becomes as 10 power 3. So here we got that the physical quantity of N2 equal to 10 power 3 dyne. So if it is 1 meter, 1 kg and 1 minute are taken as the fundamental units of the magnet of the force of 36 units. Its value in CGS units becomes 10 power 3 dynes. So let's do practice, so then we will get familiar.